Hey, welcome to whole number division. What we're really going to be looking at is two different types of division, sharing and measurement, and this is key to having kids understand anything related to division, that they can think in both of those contexts. First thing, what's going to happen here is that you should write down questions if you view this that you want to ask about and you can bring to class. So as you're going through, write down anything you need. Expect that there will be an assignment at the end that's due at the next class period. Know that you can pause the video at any point if you need to reflect on any of the ideas presented. So the first task is to write a division of whole numbers word problem that you might use with 3rd and 4th grade students. Again, I'll give you a little bit of time. You can pause it if you need to sort through making that kind of word problem. Again, whole numbers, but fairly simple, 3rd and 4th grade. Well, again, you could pause it if you need to some more, but this is usually a lot tougher for people than they think to write a division problem. Most people, when they write one, write a sharing division problem because that's mostly what the textbooks use. Some textbooks only do sharing problems, but there is a second type, measurement, that we need to talk about. And actually, we're going to discover that measurement is the easiest one to make sense of in terms of what kids actually do if they're counting to find the answer. So here's an example of measurement. I have 15 cookies. I need to stack them in stacks of 3. How many stacks of 3 can I make? Now, I always think about measurement. I can sort that out, which one it is, by thinking like I'm measuring in rulers. So if I've got 3, I'm going to go 3 and 3 and 3 and 3. It's like a 3-inch ruler that I'm measuring with because I know the size of the group. I just measure with it and see how many I can make. That's a little bit different when I do sharing. Sharing, I have 24 pennies. I want to share them. Usually you don't put this in there because it's implied, but you share them equally with 4 people. And the division that you want to know, the division question you want to know there is how many does each person get. So those are the two types. We're going to look at them in a little bit more detail. So let's look at the measurement. When I have 15 cookies, I need to stack them in stacks of 3. How many stacks of 3 can I make? Note that you know the total amount and the size of each group. You know that you're working in 3s, and you want to know how many groups can be made. And again, it's like measuring with a 3-inch ruler. And this is really important. Note the division question. How many groups of 3 can be made? So I'm just going to count the 3s that I produce and see how many there are. Just think a little bit about how a child might count to solve this problem. 15 cookies, going to put them in stacks of 3. Think about it a little bit. Pause if you need to. Okay, so I think what most likely a child would do to count this, if we're beyond physically modeling, they could actually get the physical models out, but if we're rising up a level and having them think about this on a little bit more abstract level, how would they count using their number sequence? Most of the time, this situation looks like I'm going to stack up groups of 3, so I'm going to count by 3s. 3, 6, 9, 12, 15, if they know they're counting by 3s sequence. Notice that that's really not much different than what they do when they're doing multiplication. If you ask them to do 5 groups of 3s, it's still the same thing. 3, 6, 9, 12, 15. They're just attending to a different thing. In one of them you know the total already, and the other one you're seeing how many groups and seeing how many groups of 3 you make, and the other one you know how many groups of 3 and you're going to pay attention to the total in the end. So to a child, this really, if you gave them this problem, they might, 15 cookies, put them in stacks of 3, how many stacks can I make? Many kids will just say, well, you're asking me to do multiplication. It wouldn't necessarily be division from their perspective. Okay, let's see how that's different. You kind of have to remember all those 4 things. Let's see how that's different when we go to sharing. So sharing, again, I have 24 pennies. I want to share them equally with 4 people. How much does each person get? Note that, again, we know the total amount, just like in measurement. In this case, though, we know the number of groups because we know how many people we want to share with. We know how many how many people are sitting there that we want to give objects to. So I know the number of groups, in this case is 4. What I want to know is how many is in each group, or how many each person gets. So you just really reverse those last two things with sharing and measurement. And again, it's really important to pay attention to the division question. How many does each person get? Or how many is in each group is really the division question. The division question before was, how many groups can I make? So again, think on this one. How would a child count to find this answer if he or she didn't already know the answer to 24 divided by 4? Or 24 pennies, share with 4 people, how many does each person get? So pause if you need to and think about, how would a child count? Okay, let's talk about what you think the child might normally do. And in class, if I ask this question, a lot of students will start counting this way and say, okay, they're going to count by 4. So they say 4, 8, 12. And so I stop them and say, wait, why are you counting by 4s? Because when you count by 4s in multiplication, and everything that you've always done up to this point, counting 4, 8, 12 means I'm making groups of 4. But in the context of sharing, there are not groups of 4 here. There's 4 people, but I don't know how big the groups are. And so there's a little bit of an extra difficulty with sharing division in that, honestly, if kids try to solve this, they won't know what to count by. Because if you start counting by 4s, they say, wait, or you can ask them and convince them, wait, that's not right, because counting by 4s means making groups of 4. So they have to think about how big would the group be. Well, they don't know. And so typically, for sharing division, you have to do trial and error. You just have to make up things. So I could try 4 if I want. 4, 8, 12, 16. Oh, 4 in a group with 4 people, that's not enough. So let me try, I don't know, 5. 5, 10, 15, 20 if I have 4 people. No, that's not enough. So it can't be 5. They might skip to 7. 7, 14, 21, 28. Oh, that's too much, so it's probably in between. There might be 6. 6, 12, 18, 24. Oh, yeah, that works. 6 to each of these 4 people. That's going to give me 24. So it isn't really straightforward exactly what you would count by. We'll talk in class maybe to see that in the real world you probably would use materials and distribute these like you were passing out cards. And you may try something and pass out 2 to everybody, and then that doesn't work and pass out 2 more. But if you're going to a little bit more abstract way of doing it with a counting activity, note that sharing division is more difficult than measurement because the child doesn't know what to count by. And this is assuming that the child is going to make sense of this based on what they already have sorted out in the context of multiplication. And in multiplication, you count by numbers. That means you're making groups of that size. So here's a little diversion. Y'all probably had a lot of experience with algebra, and this is going to be the next to last slide in this PowerPoint. I'm just going to go through a little bit of algebra here, and I want you to reflect on it, and then I'll ask you a question about it at the end, and this will be part of your assignment to figure out something that happened with this algebra. So we're just going to take a little diversion here. So let's just start with assuming that x is equal to 1. And you know you can do the same thing to both sides, so let's just square both sides. So x squared equals x, and by the way, that one is still okay. If x is 1, then x squared is 1, and x is 1, so 1 is equal to 1. That really looks funny, but it's not a problem there. And you know that you can do the same thing, subtract the same thing from both sides of an equation, doesn't change it, so we'll just subtract 1 from both sides. And that x squared minus 1 on the left, that's a really nice one. That probably you should recognize as a difference of squares. That will factor into x plus 1 times x minus 1. If you don't believe it, go ahead and multiply it back out. Use your FOIL method, whatever you've learned, to multiply that out. And notice that really is the same as x squared minus 1. And over here, all I did was just put a factor of 1 out front. No great reason for that, but you can multiply any number by 1. It doesn't change anything. The reason I did that is because the next thing I'm going to notice is that there's an x minus 1 on both sides, and so I can just cancel the x minus 1. And I wanted to make it clear that really 1 is what's left when I cancel the x minus 1. So now we've got x plus 1 is equal to 1, and again you can subtract 1 from both sides, and when you do that you get x equals 0. So I want you to notice what we just proved, sort of. We've proved that if x is equal to 1, x is equal to 0. That means we know now 0 is equal to 1. And don't get up and leave the class, but if that's true, then we've got no point in staying in a math class, because if 0 equals 1, then anything can equal anything, and we just as well quit. But we know that's not true, and so something must have gone wrong. Something must be wrong with this algebra, and you all have enough algebra experience, surely you can find what happened there. So you might want to write that down, because you're going to be asked to figure out what went wrong. So you can pause it if you need to write it down if you haven't been writing it as it goes. Okay, so here's what we're going to do for the assignment for the next class period. Just to give you some practice, write a division of whole numbers word problem for each type of division. So that'll be 2 different problems, one for sharing, one for measurement. You know, something simple like you would do with 3rd and 4th, 5th graders. But you know, use a different problem than we used as the sample in the PowerPoint. And then the second part is, go ahead and try to write down and be prepared to share with the class what went wrong with that algebra exploration where we have sort of proved that 0 is equal to 1.